Hi, I'm Mr. V, and I'd like to talk with you for just a moment about the first part of this activity, which is averages. And so you have a 70 on a test and a 90 on a test, and you're asked, what is the midpoint? Now, midpoint, that's a strange way of saying, what is the average? And you tell me it's 80, and then I ask you to tell me how you think of it. And there's really two ways of thinking of this. One way is to take the starting point, which is 70, and you're going to go halfway from it to 90, which would be 10 more, so it'd be 80. Or you could say, well, I added the two scores and then I divided it in two. And that would be taking the average. And this is what you might tell people that you're doing, when in actuality, this is what you're thinking. I'd say most people, when they think of this, they think, well, it's halfway between 70 and 90. And this is the equivalent of the first one. You start at 70, and then you add half the distance between 70 and 90, which is 10. So 70 plus 10 is 80. There's a couple of ways that we're looking at the midpoint here. One is this graphical solution. So if I want to go from point A to point B, and this could be any points, I just chose 2 and 3 and 6, 9 for an example, but you could go halfway in the x direction, and then I could draw a line here, and I'm going to go up to where it intersects this line between the two. And that would be good enough. But we're not going to stop there. We're also going to draw this line going upward. And you can see this is 1, 2, 3, 4, 5, 6. We go halfway, we go 1, 2, 3, and we draw a line this way. This meets at the same point, which is on our segment AB. So you could go up halfway and halfway. And this would make two triangles that are congruent. One across, let's see, to the right, 2, and to the left, to up 3, to the right, 2, and up 3. So I have 2. If I had asked you, if B is the midpoint between segment AB, what is point C? You could go all the way over to B and up, and then you go all the way over again and then up. And there's different ways of expressing this, but graphically is one that's often really good to use, but sometimes it's cumbersome and it's not able to use it because it might be maybe the points are too far apart or something. So let's look at a couple of other ways. One is using the midpoint formula. Here I've labeled for you x1, y1, x2, and y2. So when we substitute the values in here, we have x1 is 2, and add to it 6, which is x2, and x subscript 2, and then divide that by 2. And you also have the y, which is 3, y sub 1, and y sub 2 is 9. So that's this number. Well, my 8 divided by 2 is going to be 4, and 12 divided by 2 is going to be 6. So I come up with the same value that I did when I was graphing it, but I'm using this formula. And as a reminder, you might want to label the points x1, y1, x2, y2 if you're going to do it that way. Mr. Chica gave us a memory aid, and he would say, you stack, add, and divide. It's a sad calculation, and it's not really sad, but it's sad. This is a memory aid. You stack these variables, you add them, and then you divide it by 2 because you're adding two numbers and you divide by the number of numbers you added. So really, this is just an average. It's an average of the x's, and it's an average of the y's. And so this is the same as using the algebraic method or analytic, which is where you're using the formula, only he just expresses the formula a little bit differently. And then we come to this fellow. This is to do this numerically. And if you're doing this numerically, you could say, that's with the table. To go from 2 to 6 is a change of 4. And to go from 3 to 9, it's a change of 6. And if I wanted to go to the midpoint, I would go halfway. So I'm only going to go half of this distance. Half of 4 is 2. So I go 2 plus 2 is 4. Half of 6, right here, is 3. So I'm going to go halfway, and I end up at 3 plus 3, which is 6. So I end up at the same point, 4, 6. But I'm doing it numerically. And finally, the last one that we'll look at is this one. This is where it gets very interesting, because I'm going to show you this table form, only I'm going to show it to you with algebra. We're going from point A, and the change from the directed line segment from point A to point B is the vector 4, 6. I'm going to go 4 in the x direction and 6 in the y direction. So this is the directed line segment from A to B. So if I add A to A, this directed line segment, which is my change in x and my change in y, it'll take me all the way to B. That is, I take the point plus 4, 6, and it gets me to 6, 9. Now that's if I'm going all the way from A to B. What if you wanted to go only halfway? What would that look like?